Okay, guys, this is our presentation, and let me give a short background first. Our project looks like at whether Egyptian fruit bats see black rats as potential predators. The data come from several months of video recordings at a feeding platform where every bat landing and rat arrival was noted. So, the next slides. Next slide, please. Yes, thank you. Let's talk about the background, and after that, about the data sets we use. We have two fields, and the first one we records each bet landing with details like risk, reward, habit, and timing. And data set two, which is about summarizes 30-minute period showing how many beds landed, how many rats arrived, how long rats stayed, and how much food was left. And not all the fields are useful for our analysis. For example, the habit column often contain invalid entries or coordinates which don't help with our research question. The session label is also not needed since object one only asks about risk perception, not seasonal differences such as seconds after set red arrival and hours after sunset. We also found some missing or inconsistent values in the time fields, so we clean those first. And next page, please. Yeah, we decided to keep the variables most relevant to our research question from data set one risk, whether bets took risks, reward, whether they got food, and timing variables, and from dataset to bet landing number and red arrival number as direct indicators of bet and red activity, plus add minutes for how long reds were present. To make the analysis clearer, we also created some new variables. For example, we calculated risk percentage, the proportion of bet landings that were risk taking in each 30-minute window. We also summarized bet landing to foot using the median so we could compare landing behavior more consistently across time periods. And these derived features helped us connect to the two datasets and directly test whether red presents changes bet risk taking and landing behavior. So this is the part one.
For the next part, we proceed both data sites in Python. We analyze timestamps, sort by time, and clean obvious anomalies, such as invalid or blank entries in the habit field. Then we drop unnecessary columns such season, sunset, and time. Next, we located bad events from dataset 1 with the nearest start time of earlier 30-minute bin in dataset 2. After that, we aligned the start time from dataset 1 with the starting time of the relevant 30-minute bin by using merge as of. From the merge table, we found out that there are many data sharing the same start time. Therefore, we engineered the following features to combine this data: the median of bad landing to food per time bin, and risk percentage, the frequency of bad landing during the same time bin. Next slide, please. For methodology, our analysis has two tracks: descriptive comparison and an inferential test. First, in descriptive comparison, we compare bad landing activity in 30-minute windows with rest and without rest. Then we visualize the distribution of red arrival number with 0 and non-zero. Second, for inferential test, we have two different tests. During inferential A, the Welch t test, we test whether the mean of bad landing number differs between no rest and rest present windows. During inferential B, the Pearson correlation, we examine the association between red arrival number and risk percentage derived from the merged data. We use pandas, SciPy states, and matplotlib for data handling, tests, and plots. Next, please. Next slide. We treat the 30-minute window as independent for the t-test and use the Welch version to relax equal variance assumptions. For correlation, we drop rows that missing values. These are real-world data, so we interpret results with appropriate caution and note potential irregularities. Next person, please.
Yeah. Oh. So we used a histogram, t-test, and the scatter plot to get the conclusion. So our original histogram used 5 rats as the dividing line, with the two groups being cases where the number of rats was greater than 5 and less than or equal to 5. However, since the former group was too small in the dataset, I changed the grouping to 0 rats versus non-zero rats, which is this diagram. This sets up a natural comparison for landing activity and risk taking under rat presence. We will walk through the visual contrast on bat landings with rats versus without rats. So t-test shows a significant reduction in bat landings when rats are present. Specifically, mean landings without rats are about 33.61 versus 27.67 with rats. The test statistic is approximately t equals to 5.0 with p less than 0.001. So we reject null hypothesis. Practically, rat presence surprises bat landing activity in those time beings. We also used the merged group dataset. We computed Pearson's correlation between rat arrival number and the risk percentage, and visualized the relationship with the scatter plot plus the regression line. The fitted line provides an at-a-glance view of the association across time beings. From the figure, we can see that when the number of rats is larger, the percentage of taking risk is more likely to be 100%.
Then we come to the next one, the discussion.
Uh,
For the discussion, we interpret the drop in bat landing line of avoidance under predation risk. The bats are less willing to land when rats are present. At the same time, some bats still land during this rat present periods. This suggests a risk-taking behavior. They may accept the higher danger to access food, which explains the greater spread we see in the data. Together, these patterns suggest the rats are not only competitors, they act like the predator type trait, reducing overall activity but also triggering risker strategies in a few bets. Next page, please. The conclusion, the key takeaways. For objective 1, the rat presence clearly reduces bat landings. Strong evidence that bats treat the rats as traits and theories. And the second one, the risk-taking behavior is linked with the rat arrivals, through which variability. So the main story is avoidance dominates, but some bats increase their risk when they choose to forage. The next page, please. The closing and the next steps. If we extend this work in assessment 3, we're planning to add more factors, such as the season, the time after sunset, and the food availability into regression models. We would also check the using alternative time arrangements and feature choice. For this presentation, one unlisted video link assign AI usage declaration, add a code link as required. That's all. Thank you.